This is the Building Automation Monthly Podcast with Phil Zito, episode 148. Hey folks, Phil Zito here, and welcome to episode 148 of the Building Automation Monthly Podcast. In this episode, we're going to be discussing what are building automation system gateways. Been getting a lot of questions lately. I recently recorded the HVAC 360 podcast, or rather, I was a guest on the podcast, and one of the questions was around protocol integration and gateways and tying things together. And then I've been getting questions from our students around gateways. And with our upcoming system integration course later this year, I've been thinking a lot about gateways because I'm seeing more and more factory equipment, or not factory equipment, smart equipment come out of the factory is what I was trying to say, with smarts inside it, specifically protocols inside it. And there is a lot going on in the industry related to protocols. We've got potentially a new BACnet web services. We're seeing HTTP being utilized. We're seeing tagging being utilized and being specified. So there's a lot to do with protocols and data and all that fun stuff. However, the maturity level and the understanding of BAS gateways from some of the conversations I've been having with folks seems to be at the same level it's been at since I started in this industry, which is rather disheartening. I mean, there are folks out there who are putting out a lot of good content, but yet, for whatever reason, folks still seem confused in regards to what a gateway is. So in this episode, we're going to be talking through the three types of gateways. We're going to talk through then how to utilize gateways, and you are going to get my 4-step process for actually going and implementing a gateway. And I will tell you, if you hear some noise in the background, it just so happened that this recording date fell on a date where my kids are home because there is a snow day going on. Apparently, we're going to be negative 50 here in the great state of Wisconsin. That's negative 50 degrees Fahrenheit. So you may hear a little bit of noise as they are home and not at school. That's the joys of having a home office and sometimes working out of there. Anyways, with all that being said, let's dive in. So what are BAS gateways? Well, if you think about it, supervisory devices like JACEs, NEs, PXCs, they all are gateways. Ultimately, supervisory devices, which are the third layer or the second layer of the building automation 4-tier architecture. So it goes servers, supervisory devices, field devices, and inputs and outputs. So supervisory devices have existed to take field level data and convert it into network level data. So that has been the purpose behind supervisory devices. All right. And then as technology got more advanced, we added all sorts of capabilities to supervisory devices: alarming, trending extensions, analytics, user interfaces, etc. But yet we still had that need for protocol gateways and physical gateways and programmatic gateways, which, if you're wondering what the three types of gateways were, I just gave it away to you. So ultimately, if supervisory devices are gateways and gateways are gateways, what is a gateway and why are you going to use it? And how could you use it to integrate disparate systems that are either different in physical architecture, different in protocol, or require some form of data normalization in order for them to interoperate? Well, as I mentioned, in this episode, we're going to talk all through that. So the three types of gateways are physical gateways, protocol gateways, and programmatic gateways. Now, I'm assuming that you understand what physical gateways or what physical architectures, protocols, and just basic programming is. If you don't worry. I'm not going to talk at that deep of a level, probably, maybe, who knows? I tend to go down rat holes, so I might talk at a deep level, but I promise I will make it understandable for you no matter where you're at. So physical gateways are, and by the way, we're going to focus on physical and protocol gateways in this episode. And then next time we run into our IT rotation, because we're on a 4-layer rotation, right? We do a business episode, we do a sales episode, we do a BAS episode, and then we do a IT episode. And this is the IT episode, so the next episode will be a business episode. So when we roll into the next IT episode, we will go through programmatic gateways because they are they're the future, but they're also very intense and require a lot of specialized skills. So with that being said, physical gateways. Physical gateways are gateways that connect physical media together. So for example, if you needed to take wired to wireless or RS-485 to 232, or you needed to go IP to MSTP, etc., etc. Well, or Ethernet to MSTP, because IP is not a physical protocol. That's a whole nother can of worms. Just realize that if you try to equate IP with Ethernet, that is actually an error in understanding. IP is a logical protocol, meaning it does not physically exist. Oftentimes when folks are saying IP, they're thinking of Ethernet. Okay, I'll end my rant and get off my soapbox with that. So physical gateways are often protocol independent. So what that means is that they are not often specific to a protocol. You know, MSTP can travel over RS-485, but Modbus RTU can also travel over 485. So just because it is shielded twisted pair does not necessarily mean it is a specific protocol. That is something I see a lot of folks make a mistake. They go and they look at their building automation system or they look at their network layout and they're like, hey, I got RS-485, so that must be BACnet or Modbus RTU, but it's actually neither. Now, while they are often protocol independent, that does not mean that they can mix protocols. You will cause all sorts of issues if you try to put a Modbus RTU device on a BACnet MSTP trunk. Hence why we have both physical and protocol gateways. We'll talk about using protocol gateways to solve that dilemma in just a second. Now, physical gateways, they simply exist to convert physical media. Let's say you've got a building, it's MSTP, and you then want to go and transfer to another building, but that's too long for your MSTP run, so you may go and do a RS-485 to fiber to RS-485. And what will happen is that signaling will then allow you to transfer your data, and it will just go and transfer in between buildings. Now, that yes, there is a little bit of protocol switching when you're going to like fiber or Ethernet that requires IP versus MSTP. But for most cases, these physical gateways simply exist to allow you to switch physical media. Okay? Now, like I mentioned, you can go and have protocol gateways that are also physical gateways, and we'll talk about that in just a second. So if physical gateways are protocol independent and they exist to convert physical media, then why do we use them? Well, if we need to go and change to a different physical media, if we need to go and convert between two different physical medias, you'll see this a lot in LAN architectures, where you have LAN routers, which will take a FT10 field trunk and maybe convert it to EI852. And those are two different physical standards. Okay. Now, 95% of the time, you will be using protocol gateways. And from this point forward in the podcast, when you hear me refer to gateway, I'm referring to protocol gateways. The only reason I spent that time on physical gateways is so that you could understand that when we are talking about protocol gateways, we are also including physical gateway capabilities. So protocol gateway is protocol specific. Typically, it will have an in and an out on separate sides. So meaning that you will have, or rather an in and an out on both sides. So you'll have BACnet coming in, BACnet MSTP coming in and going out of the same side. And then maybe you have BACnet IP going in and out of a separate side. Now, inside these protocol gateways, you will have the capability to switch protocols, hence why they're called protocol gateways. I mean, that's pretty common sense, right? So you're switching between switching between protocols. All you got to do is buy that gateway and specify BACnet MSTP to BACnet IP, right? No, not right. You see, protocol gateways usually require design and point mapping. This is, if you've seen Field Server or BabelBuster, or heck, even Jace's, they require some design and point mapping in order for you to take points and then share those points out a different protocol. Now, protocol gateways, as I mentioned, are the most common gateway. They can extend or normalize protocols, but their purpose is primarily to do protocol switching and not protocol normalization. Now, you may be wondering what the heck I just said. Well, here's the deal. Let's say that you have BACnet MSTP, and then you have Modbus RTU. Your data types may be inconsistent. So, for example, with Modbus RTU, you can have a 64-bit message. Now, to convert that into something that BACnet could make sense of may or may not be possible without some form of data normalization. So whereas it is quite easy to have a gateway that takes BACnet MSTP and converts it to BACnet IP, because those tend to have similar sizes as far as their data types, when you're taking a protocol, maybe like a string of text from HTTP, and converting that into some form of BACnet message, which I've done before. I've consumed an HTTP command, post message, and turned that into a BACnet write property message. When you're doing that, you have to do some programming, which is primarily done through programmatic gateways, which we will not be talking about in this episode. But you can also somewhat do it in your supervisory devices if they have the appropriate gateway capabilities. Now, why do I tell you that? Why does that matter? Whenever you hear something on our podcast and you're like, okay, Phil just went down a super techie, geeky rabbit hole, I don't need to pay attention to that. I want to ask you to think to yourself, why do you think he might be saying that to me? Why do you think I am saying that to you? Why do you think I felt it was important enough for me to use that example? It's not to prove that I know stuff and that I'm smart. I am damn smart, but no, I'm just joking. I am humble sometimes. So seriously, though, I will tell you, the reason I tell you that stuff is for one purpose, because I am seeing stuff going on in the industry. I'm having conversations with large organizations that expose me to understand kind of what's coming down the pipe. And I can see that for those of you who want to have another 20 years in this industry, this is something that you need to develop skills around. So your ability to consume web messages via HTTP or CoAP from systems like audio-visual systems or just simple web interfaces, and then convert that into BAS data is an invaluable skill, and it is going to become increasingly invaluable as time goes on. I'll leave you with that. Just think about what I told you, and let's dive into the 4 steps of using gateways. So a lot of folks have asked me, hey, how do I use gateways? How do I design gateways if I'm a consulting engineer? How do I go and know what gateway to pick if I'm a salesperson? If I'm a technician, what do I do? Well, I have 4 steps because I've used hundreds of gateways. I used to actually be trained on how to write the custom tables in Field Server. I've written actual protocol and programmatic integrations between multiple different systems. So when I tell you these 4 steps are all you need to know about gateways, they are really all you need to know. If you master these 4 steps, you will not be on the job holding the bag because something got messed up, okay? So step 1, you need to determine the gateway type. Remember, we're not talking about programmatic gateways in this episode. So determine, am I using a physical or a protocol gateway? If you have to wonder about this, you're most likely using a protocol gateway. 9 times out of 10, you are going to be using a protocol gateway. So let me repeat that because it bears extreme importance. 99% of the time, you will be using a protocol gateway. The days of using physical gateways, it's just not as common anymore. Step number 2, you have to determine the physical requirements of your gateway. So what are the power requirements and what are the transmission requirements? Meaning, what wire types do I need? Do you need Ethernet? Is it Cat5? Is it Cat6? Is it shielded twisted pair? Is it 22.3? Is it 22.4? Is it 18.2? What is coming in to and out of this gateway from a physical perspective? Next up, step 3, and this is the step where a lot of folks mess up. You need to determine the protocol requirements, okay? So you need to figure out your point mapping. You need to figure out your addressing. You need to figure out your baud rates, all of your protocol requirements, protocol specific requirements, okay? This is the most extremely important part of this gateway. If you have duplicate IDs, if you have duplicate MAC addresses, if you have inconsistent baud rates, if you are using a subnet and then that subnet is different than the actual subnet that the gateway is plugging into, these are all things you need to understand. You need to understand what points you are mapping in. You need to make sure that the point mapping from protocol to protocol is consistent in both data type as well as making sure that the points match up. I've seen folks mess up point tables and they actually map the wrong points, and that is like one of the hardest things in the world to troubleshoot if you mismatch your points on your mapping, which is actually becoming even easier to do now that a lot of supervisory devices allow you to dynamically map protocols from one protocol to another protocol. All right, so that's step 3, the most important step. And then step 4 is install and configure the gateway. And the way I like to do this is I ensure settings by working up the OSI model. Now you may be like, what the heck is he talking about? What's the OSI model? It is, quite frankly, if you are a technical or engineering professional, if you do not know what the OSI model is, then you are really hurting yourself. You should just spend some time learning this model, because I will tell you, I can't even count how many times I've used this model to troubleshoot issues, because it is how all internet and interconnected systems communicate. They all use this model in some way, shape, or form. So as I mentioned, it's called the OSI model. It is a 7-layer model. The first layer at the bottom of the model is the physical layer. At this layer, we want to make sure that we have the appropriate power, we have the appropriate wires or channels, and that we are using the appropriate signaling. You know, if you've ever looked at setting up Modbus RTU and it asks you about bit rate and it asks you about parity, those aren't just questions that are asking you that you memorize. You really should understand why you use parity and what an even versus an odd parity bit means and what CRC is, you know, those kind of things. They're really important for you to understand. Now, some of that stuff is actually data link stuff, and some of it is actually physical. So moving right along to the second layer is data link layer. This is where we have our true protocol configuration in most cases. So for serial and bus networks, this is where most of our configuration will be. This is MSTP, this is RTU, this is FT10, it's all data link. Then we have layer 3, which is IP. So data link, right, is where we're dealing with frames, or we're dealing with tokens, things like that. IP, we're dealing with packets. And this is subnet addressing. This is your gateway addressing. This is important, but now we're making a shift from a physical physical layout and physical configuration to a logical layout and logical configuration, because IP is logical. IP is not Ethernet. IP could be wireless. It could be point-to-point microwave. It could be 4G cellular. It could be Zigbee. There's a variety of ways in which you could communicate IP, for example, over 802.11 or 802.15. 802.11 being Wi-Fi, 802.15 being mesh. Now that you've verified your configuration at the IP level, you then check out your transport level, which is not always required. But if you're using an IP system, it often is. This is where we have our ports. You've heard of UDP and TCP. Well, UDP and TCP exist at this layer 4, this transport layer. So we've configured our physical power and our wiring. We've made sure that our protocols are configured and our IP layers are configured. Now we want to make sure the appropriate ports are open. And finally, we have session, presentation, and application, which are layers 5, 6, and 7. This is something I see a lot of folks ignore, and then they wonder why stuff doesn't work. Well, protocols, believe it or not, do have versions. There are different versions of BACnet. There are different versions of LAN and Modbus. And while rare, this is the rarest of the issues with protocol gateways, you still can have mismatches in protocol versions that cause failures in the gateway. I've seen this happen, although it does not happen as often as all the other factors. Now, I realize for the past 5 minutes, I've went super uber geek on you, and you may be feeling a little overwhelmed. So here's the cliff notes. There's 2 types of gateways that we focused on in this episode, physical and protocol gateways. Physical gateways are almost always used when using a protocol gateway, and they are one and the same. Because in order for protocol gateways to switch between protocols, they often have to switch between physical media. Protocol gateways are actually really easy to configure. You just need to follow a 4-step process of making sure what gateway you're using, making sure you've covered the physical requirements, the protocol requirements, and then testing the installation and configuration of the gateway. Now, after listening to this episode, some of you may be thinking, man, this is really complicated. There's a lot to protocols. I'd encourage you to check out our BAS Protocol Bootcamp. If you've ever wondered how LAN, Modbus, or BACnet work, if you've ever been on a job and just not been able to get it to work, and you've spent days trying to get the BACnet, LAN, or Modbus system to work with another system, or just to work with itself, then you need to go through this course. So I encourage you to go to buildingautomationmonthly.com/148. Once again, that is buildingautomationmonthly.com/148. Ask any questions you have related to this topic, and also check out the link to our BAS Protocol Bootcamp course. We literally will teach you everything you need to know about BACnet, Modbus, and LAN in about 6 hours. So with that being said, thanks so much for listening to this podcast. In next week's podcast, it's going to be really cool. I'm super duper excited about it. We went and emailed our email list. We reached out on all of our social media avenues to find out why people stay at their current companies and why they would leave. And we're going to go and cover those responses in next episode. We're going to talk about how to engage your employees using their own words, how to make sure that you keep the valuable talent you have in your business right now, and how you can go and avoid losing your employees to other employers. With that being said, thank you so much for listening to this episode. If you have any questions, please do not hesitate to go to buildingautomationmonthly.com/148 and ask your questions there. Until next week, I'm Phil Zito, the CEO and founder of Building Automation Monthly, and I am so excited to have you here on the podcast. Thank you so much, and I look forward to talking to you next week. Take care.